Hi, this is Dr. Pat. We're looking at annuities, loans, retirement savings, the math for paying off a loan or saving up for retirement, that kind of thing. So the key things that I'm looking at is saving up for the future and paying off the present. So in the previous videos, I did the annuities or the sinking funds. That's basically the formula down here on the left-hand side. We were making payments to save up for the future. So our future value is what we're building up there. And it incorporated this nice formula here with I being the interest rate per period and N being the number of total number of periods. And so we were looking at this, and there's some good mathematics on how that formula is developed, but I don't get into that because I just don't have enough time. Okay, so right now we're going to get into loans, but get the idea here. Just remember all this loan savings, it's all a matter of perspective because the savings account for you is really a loan for the bank. And a loan to you is like savings account for the bank. We're basically paying money or people are paying us money for the use of money. Now, there is that scene on the run of the bank in It's a Wonderful Life where Bailey starts talking about the whole issue about where the money is for mortgages and stuff like that. Have some fun. Take a look at that, especially as the holiday season approaches. Okay, so let's get to the formula here. The key thing about loan payments, loan, is here's the formula for determining the payment. So PV is the actual starting loan amount. It's the principal, it's the amount borrowed. So that's the balance at the very beginning. This is all a formula calculating what the payment should be, the monthly payment. And it all incorporates the whole idea about every compounding period, the new balance is used to calculate the interest. And so that's repeated and repeated, and that's how we get this formula. One way to make the difference between this formula and for sinking funds is that sinking funds you're saving up, you're making payments to save up for the future. So your balance is increasing. For a loan payment, you're making payments to decrease. And how I remember this is that negative power up here in this formula right here. Basically, a negative power is fractions. What's going to happen with this formula with that negative power is the balance is going to decrease. And so that's the key thing here that I remember the two formulas. If one makes payments to build up the balance, loans make payments to reduce the balance. And it's all about that power there. Okay, if you're using the calculator, one of the things you want to be doing is the principal value is the loan amount, and then the future value you would put in zero. Because notice in this formula, it has no future value. What's going on there? The idea here is on a loan, after that number of periods, your balance is going to zero. So we want the future value to be zero. It's assumed that in this formula. And the same thing we're going to have to do for our calculator. If you're using the finance feature, the TVM solver, you're going to have to put zero for the future value. So that's one of the key things to make sure that you do when doing these problems. Okay, let's get to an example. I'm looking at a student loan that I had. I've just graduated. Now I have to start paying off this thing. And so basically I have a student loan for $7,500. I'm going to make monthly payments. I'm going to do it off in 10 years. So basically I'm going to make monthly payments so that at the end of the 10 years, I'm down to zero. But this loan has a high rate of 9%. Okay, so that's my situation. So let's figure out our numbers. Our end total number of periods we're looking at is 120. Monthly payments for 10 years, 12 times 10. Our interest rate is 9. Our loan amount, the PV present value is 7,500. Our future value is going to be 0 because we're going to pay off this loan, and we are compounding and making payments 12 times a year. And so when you plug that into the formula, if you're using the formula, see I've got the present value 7,500. I've got my interest rates per period, that's per month in this case, and then this 12 times 10 for a total of 120 payments. When you crunch that out in your calculator or use the TVM solver in solving for payment, alpha enter for the calculator, you're going to end up with 9501. So we're going to make monthly payments of 9501 in order to pay off this $7,500 loan in 10 years. Now, if you're interested, where does all that money go? So when you're making your payments, this is basically the loan modernization. Basically, the idea that I didn't pronounce that very well. Hopefully, I skipped over that. But basically, it's a breakdown of how the payments are going. So where's the interest? How much interest is there? And then what's the payment towards the principal? So if we make a payment of 9501, so that's what we calculated. Notice these two numbers right here, the 5625 and the 3878. Actually, the 3878 goes towards the loan to reduce the balance, the principal, and then basically the 5625, that's the amount of interest because it's our interest right there. This 0.0075 represents the interest per month, that or the rate per month that we'd calculate. And so then that's what happens. And so then at the end of the first month payments, we don't reduce the balance by 9501. We only reduce the balance by 3876. And so our new balance here is what we use to calculate next month's interest. And so the interest payment, yes, it's going down. And then more of our money, the payment's still going to be 9501, but more of that 9501 is going to go towards reducing the balance, towards paying off the principal. And so that's one of the key things about loans you want to be careful about. At the beginning, most of the payments or a large chunk of your payment goes towards the interest, not towards reducing the balance. Okay, thanks. I've got another example coming up in the next video. Hope this helped.